Good afternoon, everyone. Welcome to today's course series portfolio webinar, understanding the third step of the adhesive selection process, determining are there any end-use requirements. I'm Jim Berzaitis, the Marketing Communications Manager for Performance Tapes North America, and I'll be your moderator for today's event. For clarity, the audio lines will be muted during the presentation. To submit a question, use the chat tool located on your screen. Time permitting, all questions will be answered at the end of the webinar. If your question is not answered during the event, we will contact you directly to provide an answer. Upon registration, you should have received a digital copy of the course series product selection tool. It would be beneficial to have a printed copy of the file handy or the file open for reference during the presentation. For future reference, if you do not have a hard copy of the tool, please contact your account manager. Today's presenters are Avery Dennison Performance Tapes Application Engineer Scott Krusinski and General Industrial Product Manager Deanne Lewis. I will now hand it over to Deanne to take us through the presentation.
Thank you, Jim. And thank you, everyone, for taking time out of your day to join us for the third webinar in the series, Step 3, Determining if there are any end-use requirements. Hopefully by now, everyone has been working with the course series tool and is finding the program easy to use. Our goal is for it to be easy to do business with Avery Dennison Performance Tapes. In addition, we want to educate your teams, gather the key informational needs so your customers can be quoted quickly and accurately. Next, Jim. Thank you. So getting started is simple. The course series tool is meant to streamline the adhesive selection process by walking you through 4 simple steps. So now we'll pause for a brief moment while you make sure that you have your product selection tool ready to use. It will make it much easier to follow throughout the presentation if you have it handy. Okay, so hopefully everyone has the tool available right now. We're just going to do a quick overview of the course series tool and how it works. It's designed to walk you through the tape selection process. Step 1 being lamination, understanding what we'll be laminating to. Step 2, understanding the surface energy that the part will be bonding to. Step 3, considering end-use requirements, which will be what we're covering today. And step 4, choosing the construction and liner combination that will be most friendly for the manufacturing process and in the application. So if you could turn to page 14 and 15 of your course series guide, I'm just going to briefly walk you through how the tool works. So on the left-hand side, on page 13, is the general purpose product. You can see the adhesive family is in color-coded there for your reference. As you walk from left to right, you'll see the product name, the construction type, the liner options that are available, the spec number. Each of the products that are within the course series portfolio are 1-roll MOQs. You can see the designated width and length, which is the minimum. And you can see each of the products that are in the course series brochure are 4-day lead time. In addition, we have the thickness in mils broken down by the unwide side, the carrier, the liner side adhesive, the liner, and then the total thickness with and without the liner. Now I'm going to turn it over to Scott.
Thanks, Deanne. Thanks, Jim. And thanks, everybody, for tuning in. So as you've heard earlier, today's focus is going to be around step 3. What are your end-use requirements? Step 1, we've thought about what you're laminating to and what tapes would be compatible with what you would be laminating to. In step 2, we're considering what type of substrate the converted part would be bonding to, and the main factor for that would be surface energy and determining the best combination of adhesive to work for those two materials. And now step 3 is really understanding what's going to keep your part bonded and selecting the right tape to make sure that the part will stay bonded for the life of the end-use application. So we'll be going through the end-use requirement considerations. We have a survey that we sent you earlier, and we have some responses to go through. We'll be talking about how we test for applications. I have a few examples for us to go through and to use the product selection tool to make the best selections for different tapes. And then we'll also talk about the Avery Dennison OEM certification finder. So again, step 3, this is how do these parts stay stuck, right? So there's going to be a variety of factors that affect the adhesive performance and making sure the part stays bonded. And that would be one of the main considerations is service temperature. And this is not the temperature at application, but the temperature that the end-use part might be exposed to. So for example, a car is assembled, there's a polyurethane die-cut part inside the car. Maybe this car is exposed to the heat wave in Los Angeles last weekend where you're at very high temperatures. So that would be the service temperature. We're going to talk about humidity resistance, solvent and chemical resistance, UV light resistance, shear resistance or load. We'll also talk about tack, which is a little different than these other requirements. Of course, we'll talk a little bit about price and cost, and then OEM specifications. So if you have the Core Series product selection tool with you, you'll see step 3 in the pamphlet. And we have a handy-dandy chart here, which is the application requirements guide. And this will walk you through those different end-use requirements and what type of tape we would recommend for it. So the first column there is going to be the adhesive chemistries. Again, as Deanne mentioned, they're color-coded, so as you move throughout the product selection tool, you'll be able to follow the colors if you're moving along by tape. The next column, we have maximum service temperature. We would not recommend a particular adhesive for temperatures above that. So, for example, you see the general purpose rubber there. 160F is the maximum service temperature we would recommend. If your application exceeds temperatures beyond that, we would not recommend that particular adhesive. Then the next few columns are denoted by a circle, and an empty circle would be low or not recommended. A half-filled circle would be that the adhesive should be good. And then for a filled circle, we highly recommend that particular adhesive when you have to consider that type of a requirement. So, for example, if you look at general purpose rubber, a lower maximum surface temperature recommendation, we do not recommend it for humidity, solvent, UV, or shear resistance, but it does have good tack, and it is lower price point. So it's not a particularly durable adhesive. As you may have learned in step 1 and 2, it's a very tacky adhesive that can bond well to a wide variety of laminates and substrates, including low surface energy plastics, but it just does not have good environmental resistance as reflected in this chart. On the flip side, if you look at HPA, our high performance acrylic, which is purple, the second row from the bottom there, it has excellent temperature resistance at 400 degrees Fahrenheit, and it has excellent resistance to humidity, solvent, UV, and shear, but it has an empty circle for tack, so it's not very tacky, it's very firm. And it is a little more expensive than those other ones. So there's always going to be a balance of properties that you need to consider. And sometimes getting the adhesive that's best balanced would be the best recommendation. So take, for example, the general purpose acrylic, the lighter bluish green one in the middle there. It still has pretty good temperature resistance, and it still has full or half-filled circles, and it's moderately priced. So it's a well-balanced adhesive for a lot of different end-use requirements. So we're going to hand it back over to Deanne real quick to discuss our survey, and then I have some thoughts on your responses.
Okay. Thank you, Scott. So as we mentioned during the registration process, we asked what are the most common end-use requirements that you encounter with your customer. The number one response was cost. Number two was temperature resistance. And number three was OEM end user specification. And then we did have number four, solvent or chemical resistance. Scott will be talking about each of these throughout the presentation. Moving on to
thanks,
the
Deanne.
second question.
Well, Yep, go ahead. Sorry.
Oh, sorry, Scott.
I just wanted to add some quick commentary on it. I'm
Sure.
not surprised at all by these responses. On the previous surveys we've done, there have been a few surprises. This one has no surprise at all. A lot of times there's cost pressures, so that often comes up, and that comes to the forefront of why an adhesive might be recommended and what a converter needs. Temperature resistance is definitely the most common performance requirement that we see pop up. A lot of times these applications are outside and exposed to difficult environments. So temperature is often one we have to consider. And then OEM or end user specifications that, as we'll find out soon here, is a main requirement oftentimes. And this being the core series, which is primarily directed towards foam and fiber and film bonding, a lot of applications go into applications that have end user specifications like automotive or appliances.
Okay. So the second question was regarding what percentage of your job are given specific specifications by the OEM or end user. We had pretty even responses. About almost half of the people said 25% to 50%, and we had a few that said 75%. We actually had one that said 100%. So Scott will be talking at the end of the presentation regarding the OEM Cert Finder. Hopefully, most of you are already familiar with that tool. It's a great resource, and Scott will give you an in-depth look at how that particular tool works, and will hopefully help you with your OEM specification needs. Scott?
Okay, thank you, Deanne. All right,
All right,
so a quick review on how PSAs bond, and this is more concerning step 1 and 2, but let's review it because it's important to understand how that works for how PSAs actually stay bonded. So there's two primary factors for why PSAs bond. The first is rheology. This is the study of the flow of materials that are elastic and viscous. Okay, so viscoelastic materials. These are solid and liquid-like materials that have properties balanced in between those. So one common example I like to give for a viscoelastic material is silly putty. Everybody knows what silly putty is. You can ball it up, and when you throw it at the ground, it will behave like a solid, and it will bounce back to you. But if you slowly stretch it out, you'll see that it begins to start flowing and stretching itself out. Pressure-sensitive adhesives are very much like this. When they're stuck to a surface, they will slowly flow out and dwell out and wet out over a substrate to maximize its bond. Okay. The other main property for why PSAs bond are around the surface energetics. Okay, these are the intermolecular forces between the actual surface of an adhesive and the surface of the substrate. Okay, and that would include things like van der Waals attraction, chemical bonding, electrostatics, interlocking, and you can imagine how that would work with the rheology. If you have a high flow adhesive that really maximizes the wet out over a substrate, it can maximize the amount of intermolecular forces, which in result means a high bond. Okay, so adhesive manufacturers generally have more control over the rheology of adhesive and an understanding of the rheology for recommending different adhesives for different surface energies and textures. And this is how PSAs bond to substrates. But today, we are concerned about how do they actually remain bonded. So PSAs and the laminated part and how they're bonded to the substrate are going to be exposed to a variety of different conditions. So there's going to be the shear loads that might be applied. So if you look at the particular picture here that has the substrate, the PSA, and the laminate, this could be like a die-cut foam, for example, and the foam maybe has to go around a corner of the substrate. As you can imagine, that foam is going to have some internal strength, and it's actually going to want to return to a flat state. But you have the PSA there preventing that from happening. But that foam might be applying stress or shear resistance on that PSA. In addition to shear, you might have temperature to consider. So you're going to be maybe exposed to high temperatures or freezing temperatures. In higher temperatures, adhesives will want to flow. And in combination with that shear stress, the adhesive might flow too much, and that could result in a failure mode as pictured on the right there, where the adhesive might split or it just might lift off, and that was the wrong adhesive for that particular application. Similar to temperature, UV light, and solvent resistance, and then just overall time are going to be factors that affect the adhesive's success, okay? And the main reason why adhesives are going to remain bonded go back to that rheology and, of course, the surface energetics, but then also the chemistry. So in terms of rheology, if you're at higher temperatures, the adhesives are going to tend to flow more. And if you have stress on that adhesive and it flows too much, it's going to fail. And then also if you choose the wrong chemistry, you might have some degradation that occurs under UV light or some type of solvent immersion. So an example I like to give there for UV light is if you had a window film bonded to a window and you're using say a rubber adhesive. Rubber adhesives are not known for great UV light resistance. And actually what begins to happen is they start to brown and degrade, and they lose their viscoelastic nature, and then they could ultimately fail. So if we move to the next slide, Jim. So how do PSA tape manufacturers, and how does Avery Dennison test for these types of situations? So I'm going to take you through a few examples of testing examples. And the first one we're going to evaluate is shear testing. This is understanding the inner cohesive strength of an adhesive. And the standard way to test for this would be to use a 1-inch by 1-inch section, and you can see a picture on the right, by the way, bonded to a substrate. And in a vertical hanging mode, you're going to hang a weight. And the typical weight for that is 1,000 grams. And for static shear testing, you're primarily going to do it at room temperature, and you would measure the time to failure. So anything that fails within 1,000 minutes, we would classify as a low shear adhesive. So a rubber adhesive would likely fail below 1,000 minutes. Medium shear would be anywhere between 1,000 and 10,000 minutes. So a lot of our tackified modified acrylics, like the general purpose acrylic or the LSC modified acrylic, would fall somewhere in that range. And then you have high shear categorization, which would be over 10,000 minutes. And we actually stop the test at 10,000 minutes. That's about a week. That's generally the standard that's given. You don't need to test beyond that to determine if that adhesive is high shear at room temperature. In addition to, by the way, it's pretty cool how we do this. We have lasers that actually will detect whether or not the weight has fallen, and then there's timers along the bottom of those holders that will tell you the time to failure. We also do dynamic shear testing, where you lap two types of substrates together and you pull them apart with an inch-drawn machine. That's done, of course, in a dynamic mode, and you measure the force based off that. Okay, next we're going to talk about temperature testing and conditioning, how they're similar and how they're a little different. So at temperature testing, that could be cold or elevated. You can do the specific test at those situations. So, for example, the test I just showed you, the static shear test, we could actually do that in a elevated temperature chamber at, say, 85 degrees Celsius or 100 degrees Celsius to understand the shear strength at a higher temperature. So if you remember what I was saying about rheology, generally speaking, adhesives will flow more at higher temperatures. And if they're under the same load, it's likely the adhesive will fail sooner at the elevated temperature versus the room temperature. We can also do peel adhesion testing at elevated or cold temperatures. And the way we do that is we actually have hot boxes where we actually can put our Instron machine arms in a elevated hot box to peel at elevated temperatures. But Avery Dennison also has these giant cold rooms where we can actually bring the temperature down. It's just very much like a meat freezer for restaurants that you can go inside and actually run the peel adhesion or other types of tests at the lower temperature. Another great test that's related to how we determine the service temperature is the SAFT test. SAFT is an acronym for shear adhesion failure temperature. And that's very much like the static shear test as well, except in this situation, we're going to ramp up the temperature. We have conditioning ovens that are able to increase the temperature at a linear rate. And generally for that test, we start at 100 degrees Fahrenheit and we go up at a certain rate until 400 degrees Fahrenheit. And something like an HPA would not fail in that situation, but then a general purpose rubber would fail relatively quick at, say, 160 F. In addition to that, we can also do mandrel testing. Mandrel is when you have like a pop can, for example, and you would bond a foam die cut around that pop can. This is related to, it comes from the labels industry actually. For like shampoo bottles, you have a label that goes around a contour. That's done as a mandrel test, and we can evaluate whether or not a laminated die cut part would lift off at higher temperatures. And that also goes for final assembly. That cartoon I showed you with the part that was going around the corner, we could do that with a final assembly, expose that to a higher temperature to see if it would fail or not. In addition to at temperature testing, we also have temperature conditioning. So this is where we might expose different parts, and they're usually in a flat situation, to different temperatures for a certain amount of time. And then we would reacclimate them at room temperature to run peel, tack, and shear tests. Okay, so we can understand this is more of the degradation of an adhesive that could occur at higher temperatures. Similar to temperature conditioning would be environmental conditioning, but now we're exposing the materials to various environmental conditions. So pictured in the top right there is actually a humidity chamber. This is a temperature chamber that also can introduce water vapor for humidity. So we can control the different humidity situations. A lot of the automotive OEM specifications require something like 65% relative humidity all the way up to 95% relative humidity. And in addition to that, we can do UV light chambers. Avery Dennison has some divisions that make products that are exposed to UV light quite often, like the graphic materials or reflective materials that go onto stop signs and highway signs and trucks, where UV light performance is really important. We have the ability to test different composites in that environment. A lot of times adhesives are not exposed to the UV light because they're protected by the die cut part, but sometimes we do work with films and other materials that are permeated by the UV light, and that's where UV light resistance might be important for the adhesive. And then finally, the last environmental conditioning that I'll mention here is solvent or chemical immersions. This is interesting. You can dip die-cut parts that have been bonded to a substrate. You can dip them into beakers of a certain solvent like gasoline or transmission fluid and pull them out and measure the difference in performance that happens. You can do a quick dip. You can do it for minutes, hours. But generally, these types of things, they don't go longer for 24 hours. Okay, so now we're kind of flipping back to something that would be closely related to step 2, but it really falls more into a step 3 situation. So tack is the initial adhesion of a PSA. And while that might be related to the overall adhesion that you need to consider for step 2, it occasionally becomes an end-use requirement, okay? So maybe your die-cut part is in a quick assembly process where an operator is quickly applying die-cut parts to a small assembly, and they don't have time or good pressure conditions, so they need high tack, okay? So our chart will refer to higher tack adhesives. Conversely, we also have low-tack adhesives for repositionability. Sometimes end users are applying bigger parts in a slower way, and when they're applied, they didn't like how it was applied, so they want to be able to pull it off and reposition it. And repositionability is basically just the inverse of high tack. So you want a low tack adhesive, like HPA, for example. And I will say the time window for that is always a case-by-case basis. It will depend on the substrate and the adhesive. But generally speaking, for a low tack adhesive, you have a window of a few minutes to reposition that before the adhesive really dwells and gets a high bond. And the way we test for it, tack is, the standard way is loop tack testing. So this is pictured in the right here. It looks similar to peel adhesion testing, but here we're laminating it to a film, and we're putting the tape in a reverse loop so that the adhesive is exposed outwards, and we clamp it with the inch draw machine, and we bring that loop down and contact it with the substrate, and the arm holds it for probably just a few seconds, and then it pulls away. So there's hardly any force applied to it. It's just in the stiffness of the film in the inch draw machine going down and contacting with the substrate that applies some pressure, and then we pull it away and we measure the force out of that. So a general purpose rubber, for example, would be very high tack, and you'll see in a second here those different values. Okay, so here's some test data that I wanted to show. Adhesion failure temperature, which is also related to surface temperature testing that we do. And again, I like giving these three examples because it shows the different performance of these different adhesives. So first up, we have the general purpose rubber, and that was failing around 160 degrees Fahrenheit. So in our data sheets, we actually don't recommend this adhesive to be used for over that. On the flip side, we have our high performance acrylic, which reached 400 degrees Fahrenheit. And then the general purpose acrylic is balanced in between at 350 F. And next, if we move to our loop tack testing, you can see how the properties have flipped. So the general purpose rubber here is the highest performer at 14 pounds per inch on the loop tack test. And HPA is less than half of the general purpose rubber at 6.4 pounds per inch. And again, the general purpose acrylic is balanced there in the middle. So you can see how the trade-off of properties occurs. Generally, the tackier the product is, the lower the temperature resistance, and vice versa. All right, now I have 4 examples that I'm going to take us through. So if you have that product selection tool out, I would recommend having it out. If you don't have it, that's okay still. We'll take you through it as well. So example number 1 here, an industrial OEM is requiring a die-cut piece of polyimide film. All right, so this would be the laminate from step 1. And as you go through the, we're focused on step 3 today, but you could actually take these through and figure out what would be a good tape for laminating to a polyimide film. It's going to be bonded to aluminum, which is the substrate in step 2, for an electrical insulation application. So I'll just comment on step 1 and step 2 real quick. Polyimide film is a high surface energy film, and aluminum is a high surface energy substrate. So far, this is actually a pretty easy application in terms of tape selection. But now we're moving into step 3. The assembly will be exposed to temperatures up to 400 degrees Fahrenheit and may be splashed with coolants. So what might be a good PSA for this application? So here we have some serious considerations to think about. Okay, we have high temperature of 400 F, and we have splashing of a coolant, which is like a solvent or chemical resistance. Okay, so if we highlight on those, maximum surface temperature, quickly canceling most of these adhesives off. You have HPA and silicone, and then you also have solvent and chemical resistance. So in this situation, you're going to want to go with the high performance acrylic. And again, this is the particular adhesive. This particular adhesive is used in several different products in the core series that Deanne showed earlier. We have 2 transfer tapes with different liners, and we also have a double coated version of the high-performance acrylic. All right, so that's example 1. All right, example 2. An automotive tier, so this is like a tier 1 selling to an OEM, would like to bond a flexible heat shield, which is constructed of foil and a non-woven polyester. Okay, so in this situation, the foil is actually bonded with some other type of bonding adhesive, like a heat-activated film, to the non-woven polyester. The adhesive is the pressure-sensitive adhesive, the tape, is going to be laminated to the underside of the non-woven polyester. Okay, so that's step 1, the non-woven polyester. And that part will be bonded to a high-density polyethylene, HDPE, gas tank. That's the substrate, step 2. So real quick, just stopping there, the non-woven polyester, if you look through the guide, you'll determine that that's not particularly hard to bond to. A lot of different adhesives will work for that, but the real constraint here is going to be the high-density polyethylene gas tank. That is a low surface energy plastic. It's actually very difficult to bond to, and your adhesive options are going to be constrained, and there's going to be fewer options. But now let's take it to step 3. The PSA will be exposed to temperatures reaching 325 degrees Fahrenheit. It's going to be exposed to humidity, and then probably some occasional small splashes of transmission fluid and gasoline. In addition, the tier is asking for high tack because these parts will be applied quickly. Wow, so a lot to unpack there. So high temperature, we have humidity, and here we are going through the chart. So again, maximum surface temperature, well, a lot of our products here are listed for 350 F, so we're good there. Humidity resistance, we have quite a few options there. Solvent and chemical resistance, quite a few options there. And tack. So if you look at it, the general purpose acrylic and the LSE modified acrylic would be pretty good options. But if you go back to step 1 and step 2, you'll find that the LSE modified acrylic is probably going to be best for it compared to the general purpose acrylic, although the general purpose acrylic might be a good option as well. So that was example 2, and now we're on to example 3. We have an audio visual effects company that is designing cases for delicate lighting equipment. So think of these big lights for concerts, and they need to store them in cases, and then they need foam to protect these lighting equipment so they don't get damaged in transit or opening and putting them back in there. So they are going to be bonding a polyester foam. Again, this is the laminate, step 1, polyester foam, to an ABS plastic molding, the substrate, step 2. So if you were to look at step 1 and step 2, you'll determine adhesives that would be good for those. This is not a particularly demanding application. Polyester foam in general is easy to bond to. ABS is a medium surface energy plastic that's easy to bond to. And then we find out the step 3 related stuff. The assembly will almost always be kept inside concert halls. They are requesting low cost. So no high temperatures, no humidity, no splashing of gasoline. A pretty easy application. We're competing on cost here. It's pretty clear. They're asking for low cost. So we might have a few options that are low cost, but I would go with the general purpose rubber. Again, you don't need to consider the temperature, no humidity. It's inside concert halls all the time. We just want a low cost adhesive that will stick to these materials and will do the job. Your general purpose rubber will do a great job. Again, we have this adhesive in several different products, like a transfer tape and a double coated tape. So that's example 3. And our final example, example 4, an automotive OEM is designing for a buzz, squeak, and rattle. Sometimes you guys might see it as BSR as an acronym. So a buzz, squeak, and rattle application for the interior of a car. They would like to bond flock, which is the laminate in step 1, to polypropylene, which is the substrate in step 2. And it needs to pass automotive specifications, and it needs to be low VOC. So this is a little different than the previous examples because now we have automotive specifications to consider, and it needs to be low VOC. This isn't something we've asked of ourselves so far. So if we refer to the chart again, You can see here by the adhesive chemistry names, we have two particular adhesives, the low VOC acrylic and then the high performance low VOC acrylic. And the differences between them, the high performance low VOC acrylic is obviously higher performing. It performs better at higher temperatures, and then it has excellent tack and environmental resistance. And then if we couple that with the OEM Cert Finder, which I'll talk about in a second here, you'll find that this adhesive is used in a couple of our products that are tested extensively to OEM specifications. So the high performance low VOC acrylic is, it comes in 3 different products in the core series. So there's the transfer tape 1149X. There's a double coated tissue version of that. It's the 8270, FT8270. And then we also actually have a flock tape where we've actually incorporated the flock already into the tape design, and that's FT0900X. It's a black flock. It's used extensively in automotive. However, if a converter wanted to purchase their own flock, or maybe the OEM's requesting a white flock or a red flock, you'll have to procure that and laminate that yourself. And in that case, we would recommend FT1149X. So next, I'll show you guys the OEM certification finder here. As you can see, there was an example there. So this is our lab. It's the Painesville Innovation Center. Painesville is just east of Cleveland, and this lab of ours is ISO 17025 certified, which allows us to test and certify against automotive OEM specifications. So you can imagine all these different tests that we do. It's quite a bit to manage. So we made a user-friendly website called the OEM Cert Finder that is available to the public and available to all you to download certifications. So there's going to be over 2,300 active OEM certifications with our tapes, and it's always showing a combination of laminates and substrates to all the different specifications that we might be testing to. This list is growing. We have 2 automotive specialists who are testing to these specifications all the time. And if you don't see the particular specification or certification for the combination or the spec you need, we're always happy to test it. If it's not on there, it's just because we haven't tested to it, or it may have failed, and we will let you know. But I'll tell you, most of the time, it's just because we haven't tested to it. There's just a lot of different applications to keep up with. We're happy to test it for you guys. Let us know. Let your sales rep know, or customer service, or let me know, and we'll get to testing to it. You can access the Cert Finder at tapes.averydennison.com/OEM Cert Finder, or you can simply internet search it. You can just search Avery Dennison OEM Cert Finder, and it'll pop up there. And then we are accredited with this specification from ANAB, ANAB. We have to go through an accreditation each year to get requalified. So I'll take you through the tool and show you some of the examples. So this is what the user face looks like. It's not that difficult to understand. It's the OEM Cert Finder. There's some information and people you can reach out to for more information too. So if you wanted some other testing, you could reach out to Kyle Witham. He's an ATS engineer. ATS is our Applications and Technical Service team, and his email's there. Or Jake Towdrick, who does a lot of the testing. He's our automotive testing specialist who does a lot of the testing as well. So the way it works is you have all these different fields. You can select the OEM, the spec, the tape, the support, and the substrate. We test all those combinations to the specification. So in this particular example here, you can see the OEMs, and we have quite a few different OEMs. And there's a little differences that go on. So we have like GM, for example, and GMW. Both of those are General Motors, but General Motors has a few different specifications as different categories. Like they'll have a General Motors specification, but sometimes they'll have a General Motors worldwide specification. So that's why you might see some differences there. So we go to the next one. Here, you can select the specification. So this is much more detailed. As you can imagine, GM is going to have several different specifications. Ford has several different specifications for tapes and foams. And you can go through and select those. And there's always modifications of each one. So like, for example, we have the GMW 16443 Type 1, but we also have the 16443 Type 2 exterior cycle seat. and there's going to be some different requirements within those modifications of that specification. Next, we can select tape. So let's say you're already buying FT1126 and you have another automotive application for it. You can just start by selecting the tape and leaving these other fields open and hitting search, and you can see all the different specifications we certify FT1126 to. FT1126 is a 5mm transfer tape using our general purpose acrylic that has all those excellent balance properties, and it fits in really well for automotive. Next, we can select the support or the lamination side, aka the laminate, which would be our step 1 consideration. And by the way, you can use this tool for beyond automotive. We're primarily focused on automotive here, but it can give you a good idea and kind of works like the step-by-step process we have for the core series. Here we have much more detailed examples of what the laminate might be. So we have like low perm foam, for example, leather, foil, fabrics, but then we have highlighted here polyester foam, which is probably the most common. And then we have PEU, the polyether urethane foam, which is also very common, but different than polyester foams. And then if we move on to the substrate, again, this is the mounting side. This is step 2. You have all these different examples like painted metal, polycarbonate ABS blend, steel, and polypropylene, which is highlighted there. So what I recommend when you use this tool is you start limited. Maybe you just work with the laminate first, and then you drill down by specification or by the substrate, and you get closer and closer to what you need. And by the way, the table, the way it works is, again, you have the OEM listed, you have the spec as the second column, the tape, the support of the laminate, the substrate, and then there's the View Cert button. So on the next slide here, Jim, we click on one of those. Here are some examples of our certifications. So first, in the top left, of course, you have our contact information. On the top right, you have our accreditation. But then in the middle, for the first one on the left here, this example, it's the test report and the information you need within that test report. So the product here was the FT0900X. Again, that was one of the examples we gave. The support or the laminate is the flock. The substrate is polypropylene. And then it has information about the OEM specification. So this one is the 4 WSS M11P62A. We have the revision date on there. That's important because a lot of times the OEMs will update the specification and there will be new revisions, so we track that. And then if you move through, we test to the tape-related aspects of the specification. Sometimes the spec is strictly for tape performance, but a lot of times it's for a broader, larger assembly. So we will just test the tape-related requirements. And for this particular example here, we have an odor test. There's a wet odor test. Interestingly enough, automotive, it is important to have good odor. You don't want your car smelling bad. We also have flammability testing here, and then a fogging test. So sometimes adhesives and other polymers will outgas, and fogging can occur, and it might cover your windshield, for example. So OEMs don't want fogging in general, so there's requirements on that. So the tape requirements will be listed on the left side there. We will show the specification requirements in the middle in red, and then we'll have the result, and then we'll have the status, and that's pass or fail. And on the Cert Finder, we're only showing passing products, so all these should be saying pass. Then on the right example here, this particular specification is FT1126 to a Rogers Pour-On foam. The substrate is polycarbonate ABS blend, and the specification is the GMW 16443 Type 2 Exterior Cycle C. We have some more information about that in the revision. And then you can see with this particular specification, there's a lot more requirements than the other one. There are edge adhesion. Edge adhesion is GM's way of saying, does the part remain bonded without peeling upwards or falling off? So does it stay securely bonded throughout these different types of conditions, like 24 hours at room temperature? That's very easy. Heat aged 168 hours at 80 degrees Celsius. There's a humidity requirement. And then there's a cycle exposure where they want it cycled twice through negative 30 degrees Celsius up to 70 degrees Celsius, a humidity situation, back down to freezing, back up to humidity, back up to a high temperature, more humidity, and then repeat that. So you can see how these OEMs are accounting for all the different conditions that might occur. And then if you look down the lower section here, this is peel adhesion. These are the same conditions, except now we're going to peel the product after exposing it to that condition. And here the specification is requiring a peel adhesion of 525 newtons per meter. And a lot of times you'll have a lot of different units. So what's most common in the United States is pounds per inch. We would convert those units in our heads to understand what's easier for us if we're usually coming from a pounds per inch perspective. But that's the specification. We list the results. We also list the failure mode of the peel adhesion that occurs. And then we list the status. And then in addition to the peel adhesion, there's a cold shock test where we expose it to low temperatures and basically drop it and it can't separate. And then there's also a release liner test where the liner has to release at a certain value, which is a little more rare for a specification to have, but I can see how sometimes OEMs would require that. So that is the OEM Cert Finder. Okay, so as a summary of today, thanks everybody for tuning in this hour. This was step 3, really considering all the end-use requirements. You need to consider these things. The ones you're going to want to consider, again, are maximum service temperature, humidity, solvent and chemical resistance, UV resistance, shear, tack, price, and all of that is in the product selection tool that we have available. We try to make it very easy. Of course, you guys can reach out to your sales rep, to our customer service, and to our engineering teams for help. But we like to think that the guide makes the selection process easy for you guys. And then we also have the OEM Cert Finder. So if you're working on an automotive example and there's an OEM specification, it's a lot easier because you don't even have to think about that stuff. You can just pull up our Cert Finder, select it, get the right combination, and boom, you're done. You can print out that cert and move it along to your customer and use our product there. So as you're finding, the product selection tool is only a 4-step process. We're trying to make it easy, and today was step 3. So thank you so much. I'm going to hand it over to Jim if he has any questions that anybody has submitted. And I'll remind you guys that you can submit questions via text, and Jim would be happy to bring them up.
Yeah, that's via the chat tool. We're not tech savvy yet, but we're getting there. So the first question came in. We were talking about testing. Person asked, is there additional cost for the testing, or is this just part of business?
Oh, great question. Yeah, we do this for free, guys. Yeah, we're happy to test for you guys. We'd like to learn a little bit more about the opportunity, and the sales rep will work with you. And our lab is very happy to test for your applications. The Cert testing that we do for automotive is also free, but we're going to list it publicly online.
All right. Thank you. This is an interesting question, especially as we go into the realm of EV battery and autonomous vehicles. The person asked, is there a self-extinguishing PSA?
Okay.
Yes.
Yeah. So the answer to that is sort of. What's interesting about flame testing is you have to test the PSA in the full composite form. So you might have a foam or some other type of laminate material, the PSA, and the end-use substrate. So the example I showed earlier showed FMVSS 302. That's common for all interior automotive applications where the part is often in a horizontal mode, and we put a Bunsen burner up to the end of it. We hold on the composite for a certain amount of time, pull it away, and oftentimes it will self-extinguish, and not by any means of the adhesive. It's just because of the combination of the substrate and the laminate self-extinguishing. Now, that being said, Jim, you brought up EV batteries. I'm not sure if they specifically asked about EV batteries, but we're seeing flame resistance or flame retardants as a requirement in EV battery applications. This is an exciting area for tape usage. If you guys have applications within EV batteries, we'd be happy to work with you guys. There's a lot of developing specifications for it and changing requirements, and it's really interesting. But one of the tests for that is the UL94V, which is much more difficult than the FM VSS 302. The UL94V was adopted from electronics testing, where the composite is held in a vertical mode and the flame is held underneath that. And vertical is much more different because flames like to travel upwards. So oftentimes in those combinations, you need a very flame retardant adhesive. We have adhesives with flame retardants, and we have other silicones. I will say that those applications are not very core series friendly though, and the tapes we have for it are a little more specialty. All right. In addition to that, we also have aerospace applications too that I'll mention as well, but I won't go too deep into that. But a lot of aerospace applications require flame performance.
All right, thanks, Scott. Last question. Are general purpose acrylic water-based and high-performance solvent-based?
We have a mix of solvent-based and water-based adhesives in the core series. The general purpose acrylic is a solvent-based. The high-performance acrylic is also solvent-based. But basically where you see low VOC, that's where it's water-based. So the high-performance low VOC acrylic that we have, it performs very similarly to the general purpose acrylic, but instead of being solvent-based, that particular adhesive is water-based. So a lot of times it's good for low VOC requirements that we see a lot of times in Asian automotive OEM specifications.
All right. Thanks, Scott. So our next course series webinar, the last one for 2020, will take place November 12th. It focuses on step 4 of the adhesive selection process, and that will be the tape construction. We also want to know that coming in 2021, we have some exciting news that we'll unveil at that November webinar regarding what's in store around some bonding studies that we're putting together. Once again, thank you for attending. Later today, you will receive a post-event email. That email will be a feature story. Are there any end-use requirements? So relating to what we talked about today in a short survey. So please, continue to give us feedback via that survey. I hope you've noticed we've tried to implement as much of the constructive criticism as we could. It's always good to get that feedback because we want to make sure we continue to evolve these webinars and the course series program. Thank you, and have a good day. And we look forward to having you join us on the 12th of November.